9.2 Simplifying square roots. For this lesson, we're going to learn how to simplify radical expressions. Vocabulary. Simplest form of a radical expression. When a radical expression is in its simplest form, you cannot have a factor of the expression under the radical sign that has a perfect square factor other than 1. For example, radical 2. We only have radical 1 and 2 under the radical sign. So 1 is the only perfect square. That's okay. And 2 is not a perfect square, so we could leave that 2 under the radical sign, and that's in its simplest form. And the same goes for radical 3, 5, 7, and 10. And you also cannot have any fractions under the radical sign, and no radical sign in the denominator of any fraction. So, for example, radical 2 over 3 will be in its simplest form because there's no radical sign in the denominator. And it's okay to have a radical sign in the numerator. And let's take a look at some properties of square roots. The product property of square roots. So radical AB, A times B. You can split it up and let it be equal to radical A times radical B, where A is always greater than or equal to 0 and B is always greater than or equal to 0. So here we have radical 9 times 7. And we can split it up to be radical 9 times radical 7. Therefore, we know that radical 9 is a perfect square, and we can let that be 3 times radical 7. And this would be the simplest form of this radical expression. And for the quotient property of square roots, you can have radical A over all over B. So radical A over B, and we can split it up to be radical A over radical B. Again, A is positive, A is greater than or equal to 0, and B is greater than 0. B cannot be 0 here. And remember, according to the definition of simplest form of a radical expression, you cannot have a radical sign in the denominator. Okay, so how do we get rid of that? The property is continuous. So radical A over radical B. So you multiply both the numerator and the denominator by radical B. So we have radical A, B over B. Okay, but for the numerical example we have here, after they split up the numerator and the denominator, we notice that you have a perfect square, radical 4. So that would just be equal to 2, and you no longer have a radical sign in the denominator, which is perfectly fine. Okay. So guided practice, simplifying the radical expression. Use the cake method to help you define perfect squares. So 180 and I know I have 36 times 5 to be 180. So I can split this up, and the radical of 36, which is also a perfect square, but be just 6, and radical 5, can't do anything else with that, 6 root 5. And here 63, and now I can split it up to be 9 times 7, radical 9 times radical 7, 3 radical 7. And here we have 4 times 3. Radical 4 times radical 3 goes 2 root 3. 48. We're going to have 16 times 3. See, my goal is to look for perfect factors with perfect squares. 4 root 3. And here, split the numerator and the denominator up. Radical 13 over 6. 15 over 16. So your answer is radical 15 over 4. We have 9 over 2. Just leave it in proper form. That's totally fine. Radical 7 over 5. Simplifying a variable expression with radical signs. So again, we can have six times 4 times s squared. So we can split that up, and we could take the square root of this to be 2s radical 6. And this one, six times 9t squared, and radical 9t squared times radical 6. So you're going to have 3t. And the same thing goes for this one. 16 times 2 over n squared. So radical 14 times radical 2 square radical n squared is just n. For radical 2 over n. And that's it.